If you think this is just an ordinary rock, you'd be wrong. Because this tiny dot gave humanity its first glimpse of a world actively burning. A moon where the ground erupts, lava flows endlessly, and the surface is so violently alive it reshapes itself every few months. When Voyager 1 flew past Jupiter in 1979, scientists expected to catalog a few dead moons and move on. What they discovered instead was the most volcanically active object in the entire solar system, a place so hostile it makes Earth's worst volcanoes look calm. Its name is Io, and the footage Voyager sent back changed everything we thought we knew about planetary geology. In 1977, NASA launched Voyager 1 on a mission to study the outer planets. The goal was simple: fly past Jupiter and Saturn, take some photographs, gather data, and continue into deep space. No one expected revelations. The mission was about mapping, not discovery. As Voyager approached Jupiter in early 1979, the gas giant dominated the view. Massive storms swirling in its clouds, a planet so large it could fit 1,300 Earths inside it. Orbiting this giant were dozens of moons, most expected to be cold, dead, and cratered like our own moon. Scientists assumed Jupiter's moons would be geologically inactive, frozen relics left over from the solar system's formation, pockmarked with ancient impact craters, utterly lifeless. Then Voyager's cameras turned toward Io. The first images came back strange. Instead of a gray, cratered surface, Io appeared in vivid colors. Yellows, oranges, reds, whites splashed across its surface like a diseased pizza. There were almost no impact craters, which was bizarre. Every other rocky body in the solar system is covered in craters. They're the scars of billions of years of cosmic bombardment. But Io's surface looked fresh, smooth in some areas, chaotic in others. Patterns that didn't match anything scientists had seen before. At first, some thought the camera was malfunctioning. Maybe the color sensors were broken. Maybe the data transmission was corrupted. Then, navigation engineer Linda Morabito noticed something in one of the images. A faint plume rising from Io's edge, extending hundreds of kilometers into space. It wasn't a camera error. It was a volcanic eruption. The discovery hit like a shockwave. Io wasn't just geologically active, it was erupting violently, continuously, on a scale Earth had never experienced. That plume Morabito spotted was sulfur dioxide gas and volcanic debris being launched 300 kilometers above the surface at speeds of over 1 kilometer per second. As Voyager transmitted more images, scientists counted multiple active volcanoes, lava lakes, calderas, flows of molten rock stretching for hundreds of kilometers. Io's surface wasn't static, it was being constantly resurfaced by volcanic activity so intense that old craters were buried almost as soon as they formed. This was the first active volcanic eruption ever witnessed beyond Earth, and it was happening on a moon smaller than our own. Here's what makes Io so extreme. Io orbits Jupiter at a distance of about 422,000 kilometers, close enough to be caught in the planet's crushing gravitational field. But Io isn't alone. It's in orbital resonance with two other large moons, Europa and Ganymede, which periodically pull Io into a slightly elliptical orbit. Every time Io swings closer to Jupiter, the planet's gravity squeezes it. When it moves farther away, the grip loosens. This constant stretching and compressing, called tidal flexing, generates enormous internal friction. That friction produces heat, enough heat to melt rock. Io's interior is essentially a furnace. Molten magma churns beneath a thin crust, and wherever the pressure builds too high, the surface ruptures, ejecting lava, sulfur, and gas into space. Io has over 400 active volcanoes. Some erupt continuously. Some produce lava flows over 100 kilometers long. Surface temperatures in lava lakes can reach 1,500 degrees Celsius, hot enough to melt titanium. The environment on Io is apocalyptic. The surface is covered in sulfur compounds, giving it that yellow-orange color. Volcanic plumes rain sulfur dioxide snow back onto the surface. The atmosphere, though extremely thin, is toxic, composed almost entirely of sulfur dioxide gas. And because Io orbits so close to Jupiter, it's constantly bombarded by intense radiation trapped in the planet's magnetic field. Standing on Io's surface, you'd receive a lethal radiation dose in minutes. Even if you somehow survived the volcanoes, the heat, and the toxic atmosphere, Jupiter's radiation belt would kill you. Io isn't just geologically active, it's one of the most hostile places in the solar system. A few months after Voyager 1's flyby, Voyager 2 arrived at Jupiter and photographed Io again. The volcanoes were still erupting, but the surface had changed. Lava flows visible in Voyager 1's images had cooled and solidified. New eruptions had started in other locations. Entire regions of the surface looked different. In just 4 months, Io's landscape had been reshaped. Scientists realized they weren't looking at an active moon. They were looking at a world in constant transformation, a planetary body that erases its own history every few centuries through relentless volcanic activity. Io's surface is, on average, less than 1 million years old. For comparison, Earth's oldest rocks are over 4 billion years old. Io is geologically immortal. It never stops changing. Before Voyager, scientists believed that small moons were geologically dead. Without enough internal heat or radioactive decay to drive volcanic activity, they should have frozen solid billions of years ago. Io shattered that assumption. It proved that gravitational forces, tidal heating, could keep a small world volcanically active for billions of years, even without sunlight or a molten core from formation. This discovery didn't just change how we understood Io, it changed how we thought about every moon in the solar system. Scientists began re-examining Europa, Enceladus, Titan, wondering what other moons might be hiding active geology beneath their surfaces. The idea of ocean worlds with subsurface liquid water heated by tidal forces came directly from studying Io. Io didn't just show us hell, it showed us possibility. Voyager 1 and 2 are now beyond the solar system, drifting through interstellar space, their power fading. But the footage they sent back from Io remains one of the most important discoveries in planetary science. A tiny moon, caught in the gravitational grip of a gas giant, erupting endlessly, reshaping its surface, launching plumes into space, radiating heat like a miniature star. Io is proof that the solar system is not a static graveyard. It's alive in ways we never imagined. And sometimes the most violent places hold the most profound truths.